Hello everyone, welcome to my lecture. Here in this lecture, I am going to explain another topic of this new chapter of class 12 NCERT textbook, which is known as determinant. The determinant is totally based on matrices. In the previous lectures, we have discussed about matrices, operation between matrices, different types of matrices, and so many different properties of matrices already we have got. How can you find out the inverse? All those topics we have explained. So now we are going to start the next chapter, which is totally based on determinant. So let's start the video. What is determinant actually? A determinant is nothing but a number, maybe real or maybe complex, which is associated with any square matrix. Whenever we will consider a square matrix, maybe of order 1 by 1, maybe of order 2 by 2, 3 by 3, 4 by 4, whatever it may be, if we consider a square matrix, for that square matrix, we can easily assign a real number or complex number. We can easily assign a value. That value is known as determinant. So determinant means what? It is nothing but a number, maybe real or complex, which is associated with a square matrix. That means we can easily find out the determinant of a square matrix only. We cannot think about the determinant of a rectangular matrix. So in this chapter, determinant কোনবিলাক matrixৰ ক্ষেত্ৰত applicable হয়. Determinant is a value associated with what? A square matrix. For example, let us consider a square matrix 1, 2, 3, 4. For that square matrix, we can easily assign a value. Any real number we can easily assign. This element or this number is a real number, maybe real or maybe complex. For any square matrix, we can easily assign a value. তামানে যিকোনো স্কয়ার ম্যাট্রিক্স কনসিডার করে তার করেসপন্ডিং যেটো ভ্যালু থাকে, maybe যেটো নাম্বার থাকে, maybe real or maybe complex, that number is known as determinant of the square matrix. এটা কথা বল তোমালোকে ভালকে মন কৰাছো. This is nothing but the just like as the concept of function. If function লিখা নহয় এবাৰ function means what? It is an which will convert it. Function is an operation which will convert an element to the another one. যিনি কি এটা element ক আনটা element লৈ convert কৰে. But function means what? Whenever two sets will be there, if we can easily relate all the elements of the first set যেটা particular element of the second set or কোনোবা না কোনোবা element ৰ লগত relate কৰিম, তাক function বুলি কোৱা হয়. That means to be a function, each and every element of the first set should have a uniqueness. Here we have an element consider for corresponding kiba ami value pam. That means you will get an image for that element. So determinant itself is a function. Think about it. So determinant ki hoy? Determinant is a function hai. So determinant itself is a function. But remember, under a determinant, what type of matrices? Here this is a set of matrices. What type of matrices you can consider? You cannot consider all the possible matrices. You have to consider what type of matrices will be there. Here, square matrix will be there. Square. If we consider any square matrix, for that square matrix, we will have a value, maybe real or complex. Any square matrix you can consider. But remember, to determinant is a function where the first set is the set of all square matrix. Here you are not supposed to consider rectangular matrix. Karon rectangular matrix or corresponding ami value assign koribo normal. ঠিক আছে, কিন্তু স্কয়ার ম্যাট্রিক্সৰ যিবিলাক corresponding value assign কৰো সেইবিলাক determinant বুলি কয়. So determinant itself is a matrix. Function where the first set is a set of all the square matrix and the second set is what? It is a set of real or complex numbers. আমি এনেকা সেটৰ কথা ভাবিম, this is a set of real or complex numbers. Suppose y. Y is a set of real or complex number. If we consider any square matrix, maybe of order 1 by 1, 2 by 2, whatever it may be, for that matrix you will get a corresponding value, and that value is known as determinant. For example, suppose if A is a matrix, square matrix, then under the function determinant, f is a function suppose determinant, then we will have a value for it. What is y? Y is maybe real or complex number. It is the image of what? The square matrix A. So what we have got after having the explanation, we have got that. So determinant itself is a function which is defined from the set M. What is M? You can use any letter to represent the set. It is a set which contains all the square matrix. And what is the second set? The second set is Y. You can use any symbol to represent it. It's either real number or complex number. So determinant itself is a value. related to what? Value of a square matrix. Determinant is nothing but a number. Determinant is a number. Determinant itself is a number, maybe real or maybe complex. This is related to what? A square matrix always. Okay, it is generally represented by, you can easily write down, if suppose A equal to Aij is a matrix of order n by n, then determinant of, it is always represented by determinant of A or determinant of A or delta. These are three, this is not modulus, okay? This is determinant symbol, just like as modulus only. Determinant of A or determinant of A, or if A is a matrix, then this symbol will be known as determinant. Okay, if it is a real number, then it will be known as modulus. Okay, and this is nothing but a delta. This is a different representation of determinant of a matrix. Okay, so I think we have, I think you have got it. Actually, what is determinant? Determinant is a value associated with what? Square matrix. If we consider a square matrix, for that square matrix, one specific number will be there. That number is the determinant of the square matrix. Okay, how can we find out the value of a square matrix? So, step by step. So, determinant can also be considered as a function which is defined from a set M which contains all the square matrix to the set Y, just like addition from M to Y. What is Y? M is a set of all square matrix. What is Y? Y is a set which contains either real or complex numbers, where f of A is equal to, suppose, Y, where A belongs to the set of square matrix and Y belongs to the set Y, where Y is the set of real or complex number. Complex number. What is M? M is the set of all square matrix. Very important concept. So determinant itself is a function. Okay, our determinant itself is a value which is associated with a square matrix. Now we are going to find out the value of a square matrix of order 1 by 1. Suppose, let us consider matrix A. Suppose 5. Let us consider A which is of order 1 by 1. Then its determinant value. A is any scalar quantity, maybe positive or maybe negative, whatever it may be. So then determinant of A will be determinant of A is equal to A. For any square matrix of order 1 by 1, the determinant value itself the number, or itself the element is in the matrix. A is a matrix of order 1 by 1 where the element is A is any scalar quantity, then determinant of A is equal to what? Itself the element. If it is determinant of minus 2 is equal to, determinant of minus 2 is equal to minus 2, it is not modulus, okay? So determinant of 5 is equal to 5, like that. But remember, it should be square matrix. Okay, that is, if A is equal to determinant of, is a matrix of order 1 by 1, then determinant of A is equal to what? Determinant of minus 5 is equal to minus 5. So this is the explanation. So how can we find out the determinant of a square matrix of order 2 by 2? Let us consider a matrix. Square matrix means order 2 by 2. 2 rows, 2 columns. 2, 2. How can we find out? So determinant of A, or it will be represented by delta, or you can say the determinant of A. How can we find out? Listen carefully. So it is the representation A11, A12. They are any scalar quantities. 21, 22. They are any scalar quantities. Whatever elements will be there in place of it does not matter. Maybe real or maybe complex quantities will be there, but whenever you find out the determinant of a square matrix of order 2 by 2, then what will you do? In case of square matrix, always diagonal elements are there. I mean, diagonal element, what will you diagonal multiply koriba? That means we will multiply A11, A22. Square matrix of 2 by 2. So like square matrix, first of all we will try to multiply diagonally. Then minus sign should be there always to have the determinant value. Then we have to multiply 2, 1. Then it will be A, 1, 2. This is the formula. For example, suppose A is a matrix of order 2, minus 3, minus 4, minus 1. The determinant of A is equal to what? 2, minus 3, minus 4, minus 1, Symbol is different. This one is matrix. This is nothing but an arrangement. So determinant of A means itself a number, maybe real or maybe complex. Depending upon the quantities, this one may be real or may be complex. So it's obviously it's a number. So first of all, we'll try to multiply diagonally. Already you have got it. First of all, diagonally multiply 2 into -1. Then minus sign should be there. Then you have to multiply the non-diagonal elements. Non-diagonal means these elements you have to multiply. -4 into -3. Okay. Then what is the answer? -2. Minus plus -12. What is the answer? -14. What you have got? So determinant of A, it is an arrangement. Actually, matrix is an arrangement, but determinant is nothing but a number, maybe real or maybe complex. Maybe zero also, whatever it may be. But determinant itself is a number associated with what? Associated with a square matrix. So in this way, we can easily find out the determinant of a square matrix of order 1 by 1 and 2 by 2. In the next video, I will try to explain how can you find out the determinant of a 3 by 3 matrix. Okay, so let me recall once again. What is determinant? Determinant itself is a number associated with a square matrix. You can say that it is a function also. Already you have got how can you find out the determinant of a 1 by 1 matrix. It is a number itself, and square matrix of order 2 by 2. I hope you have got my point. Thank you so much for watching the video. Thank you.